Dr. Lisa Janae, Director of Erikson's Early Math Collaborative, and doctoral student Joanna Skurlatos will present What's the Big Idea? Foundational Math for 3 to 6-year-olds. In this session, they will explore Erikson Institute's top 5 big ideas of early math and think about how adults can engage preschoolers and kindergartners in the math all around them. Participants will have fun with math and get ideas for sharing the joy. Please welcome Lisa and Joanna.
Hello, I'm Lisa Janae from the Erikson Institute Early Math Collaborative.
And I'm Joanna Skurlatos from the Erikson Institute Early Math Collaborative. And welcome again to everyone, and thank you for choosing to spend your time in our session today. Our session's What's the Big Idea? Foundational Math for 3 to 6-year-olds. Lisa and I are very excited to have you here today to engage in the big ideas of early math with us.
So we're going to start with a little math thinking for us adults. I want you to look carefully at the picture you see on your screen. We know it's not the same as actually getting to be somewhere and touch things, but there's a lot to see. We want you to look at it very carefully and think about what you notice. Maybe if you like to make notes, jot some notes down. What things, what details, what do you notice in this picture?
Well, Lisa, I noticed that there is balloons, and I also noticed there's some strings on those balloons.
Yeah, I was noticing that there's a purple one. I love purple. And I noticed that there's a lot of other different colors. I wish there were more purple ones because that's my favorite color. I also was noticing that there's a very blue sky and puffy clouds behind the balloons. So there are many things that we can notice in this picture.
Well, now that we talked about some of the things that we noticed in the picture, let's figure out how many do we see in this picture. So again, take a moment to think about how many you see. Again, feel free to jot down your notes as you're thinking about that question. How many do you see in this picture?
I see 4. And then 3.
I see 7, and I also see 2.
I see 1.
I see 9.
I see 2. Lots and lots of numbers. What does all that mean? We have so many different numbers. We can't figure out which number we should be talking about unless we think about how many of what. Are we talking about how many balloons? Are we talking about how many clouds?
It seemed like a pretty simple question, Lisa, until we started pulling it apart.
I know. I think you said you saw 9. I was wondering if you saw 9 balloons.
I did see 9 balloons, but you know what? I also see 9 strings.
Oh. And when I said 1, I was back to thinking about my purple balloon, that I see only 1 purple balloon. But I also realized I could say that there's 1 bunch of balloons.
Oh, that's true. And I was looking at, even though I said there are 9 balloons, I also noticed that there's 7 balloons in the outer ring and 2 balloons in the middle ring.
Right, and I saw that there were 4 that are in the front and 3 that are all the way in the back. And then right at the end, I remember I was thinking there are 2 big puffy clouds. But as I look at it more now, I'm thinking, I don't know how to say how many clouds because there's all those little wispy bits. I'm not sure how to count the clouds. I'm not sure what 1 cloud is. Wow. It seemed like a really simple question. But you can't answer how many if you don't think about how many of what. And you can't even think about what sometimes until you define them. We, I think, all agree on what 1 balloon is or what 1 bunch of balloons is. But it might not be so obvious to decide what 1 cloud is. And is the sky always 1? Lot of interesting questions.
That's true. We saw so many different ways to be able to look at this, and we were really using attributes to help us to determine what we're looking at in the photo. That helped us to really be more precise as we were talking through how many of what, and to be able to define our set. And we know that this type of precision and logic is really foundational to math. Now, you may not have known it, but we've already started thinking about a couple big ideas around early math. One big idea of sets is that attributes can be used to sort collections into sets. So in the last example, first we described attributes of what we saw. We thought about those attributes, like Lisa mentioned, we thought about the color of the purple balloon, or the balloons in the front versus the back, or the balloons in the outer ring versus the balloons in the inner ring. And that helped us to define what was the set that we were actually counting. And then once we actually made those sets, we could further define them by their numerosity. This brings us to our next big idea of number sense. And that big idea tells us that quantity is an attribute of a set of objects, and we use numbers to name specific quantities. So we were able to specifically say that there were 7 balloons in that outer ring and 2 balloons in the middle ring. So even though we're talking about balloons in both of those sets are quite different because they have, if we're looking at the attribute of quantity. But on the other hand, we talked about 9 balloons and 9 strings. And when we're thinking about the attribute of quantity, we can see those two sets of 9 strings and 9 balloons as the same because they have the same attribute of that 9-ness. Even though, like Lisa mentioned, we know that balloons and strings are very different in many other ways.
So we want you to do a little more math thinking because we love to think about math and play around with math. So we have another activity. Look at this set of 4 objects and think about which one doesn't belong. There's 4 things shown. They were in the photo, and one of them doesn't belong. Look at all of them. Choose one that you think does not belong, and be prepared to justify your choice. How would you justify your choice? That's an important thing. So we're giving you just a moment to examine these 4 objects and think about them and try to decide which one doesn't belong and why it doesn't belong. And again, if you're a note taker, you might jot down your ideas so you keep track of them. So Joanna, what would you say? Which one doesn't belong? And using letters to A, B, C, and D. I think you'll understand in just a moment.
Yep. So I was looking at A, Lisa, this one up here. Just like you said, you can see which one it's associated with here. And I was thinking that A doesn't belong because it's the only one that doesn't show quantity.
But it says 5, Joanna.
It does, but it's the only one that has a numeral of 5, and it's not actually showing the quantity of 5.
I see. I have to know that means 5. It doesn't show me.
Yeah.
All right. Well, I was thinking that B did not belong because it doesn't represent 5 in any way. So the numeral 5 doesn't show us 5, but it is 5, and the other 2 have 5 dots, so that B was the one that didn't have any 5 to it.
Oh, that makes sense too. I can see how you thought that, Lisa. Well, I guess also, I was thinking that C could also not belong because it's the only one that's not the same size as the others. This one is much smaller.
You're right. It's smaller. The other ones look like they're all pretty identical in size, and that one's smaller. But D could also not belong, Joanna, because it doesn't have a white background and black printing. It's blue with white on it.
That's true.
So
that's true.
That is really interesting. Joanna and I came up with a way for each one of them to not belong, and it depended on which attribute we chose to pay attention to. We could also say they're all the same in a variety of ways. They're all dice, they're all cubes, they all have quantity and numerals represented on them. But there's a reason for each one of them that it doesn't belong. And you might have had some other ideas. When we've done these kind of activities in groups of people, sometimes people come up with many different reasons that a particular one cannot belong. But in any case, we had to look carefully at their attributes to decide. So we looked really carefully at attributes, like Joanna was talking about earlier, that attributes help us to define objects and sort them and make them into the groups that belong and ones that belong in a different group. And one of those attributes that we were thinking about in that photo there with the 4 different number cubes was the attribute of numerosity, quantity, and how things were represented. So we used these 2 big ideas very carefully in thinking about which one does not belong. We went back to use these big ideas.
So now we're going to transition and we're going to watch a couple of videos to see how children interact with some of these big ideas. So you all as adult learners have had some experiences now working with these big ideas, but we want to have an opportunity to see how children will work with these ideas as well. So the first video that we're going to watch is a clinical interview with a preschool child. So keep in mind, this isn't a typical interaction between a child and a teacher. It looks a little different. But as you watch this first video, think about what evidence you're seeing of the child's thinking, as you can see or hear that evidence, and also think about what evidence that you can see or hear of the adult's thinking.
Can you make some other kind of groups with those racks?
This big, this small.
Okay, so that's a big one you said, and that's a small one. So you want to put those down?
They're for heavy.
It feels heavy? Okay. Are there other ones like that? No? There any ways you can think out to put those in some groups?
They're for not heavy.
That one's not heavy?
They're for heavy.
That one's heavy?
They're for not.
That one's not heavy?
No.
No? So is there any way we could put these in groups?
Because you can put the book. I like the big ones in the group.
You want to put the big ones in a group? Are those the 2 big ones? Are there any other ones that are big ones? That's a big one? You can put your big ones down, then we can see them. Are those all the big ones? So these are the big ones? What about these ones?
I want to do this now.
So then what are these ones? These are the big ones you said. What are these ones? What are you going to call those ones? You told me these were the big ones. What are these ones?
Small ones.
They're the small ones? Okay. You're going to line them up? Go ahead. You can line up the small ones. So you said this line is the big ones and this line is the
Small ones.
As everyone was watching, you might have noticed a few different things. This might have been some of the notes that you took down as you were watching the video. You might have noticed that the child needed some support to get started. We saw Lisa offering some prompting to the child to help them get started with their sorts. You might have also noticed that the child was focusing on observable attributes. So the child at first was talking about which ones were big and little, and then the child looked at heavy and not heavy by using her hands to try to figure out that observable attribute, by which one carried more weight to it. You also might have noticed that the child organized this set into lines. So she lined up those big ones first into a row, and then she lined up those smaller ones. As you were watching the adults, you might have noticed that Lisa had asked, are there any other ones? So this was a way to encourage the child to see if any other of those rocks would be able to have that same attribute and fit into that group, into that set. And also, Lisa was encouraging the child to label the set. And we know that as we encourage children to label sets, it helps the child to verbalize the attribute that they're using to define that set and defining their group. You might have noticed some other things too as you were watching the video, but these were some of the main points that we wanted to be sure to pull out here today.
We're now going to watch another video, and this is a different sort of video. It's also one produced by the Early Math Collaborative, but instead of being a one-on-one interview sort of situation like I was doing with the child and the rocks, this is a planned math activity that the teacher is leading. And the teacher is spent some time getting ready for it, and she is now doing it with this group of kids. You will see there's two groups of kids in different parts of the video because this was a small group activity, and she did it several times over the course of a few days until she had done the activity with all the children in her class. So you will notice that at one point in the video, the children switch. But again, we want you to be thinking about the thinking. I want you to think about the thinking. What evidence do you see or hear of the children's thinking? But also, what evidence do you see or hear of that teacher's thinking? Because this is an intentional and planned activity. So the teacher's been doing some thinking too.
It's important to do the lesson, Feel for Shapes, in my preschool classroom because I think the children need much more experience talking about shape attributes and being able to describe what makes a shape because they are so used to just naming shapes. Today we're going to look at our story again. Do you remember what our story is about? Right. It's called Color Zoo and it's about shapes. What is it first?
A star.
There's a star. Okay, let's move on. And the first shape that's a part of our animals is a circle. How do you know it's a circle?
Look how we saw it.
Right, but tell me about it's round.
It's curvy.
And it does not have any pointy sides. What about the next shape?
This is a triangle. Triangle.
Okay, tell me about the triangle.
It's upside down. It's upside down.
It don't matter what way it is, it's the same, it's still a triangle.
Okay, Mario said it doesn't matter which way it's turned, it's still a triangle. Because what does it have? Three sides. And what else? Three points, right? I was really pleased to hear a couple of the students during the lesson say that, no matter which way the shape goes, it's a triangle. No matter which way it is, it's still a triangle. Unprompted from me. I was surprised to hear that and pleased that they've internalized that. Our story Color Zoo is all about the shapes. And I have some shapes with me. Would you like to see them? Yes.
Behind you.
Yeah, they're here.
Me too.
So I have my shapes here in my mystery shape bag, and I'm going to set them out. I want to talk to you a little bit about these two triangles, okay? Can you tell me what is the same about these two triangles? What's the same about these two triangles?
They're not matching.
Okay, one at a time. Nikayla?
Both of them got straight sides.
Okay, both of them have straight sides. What else is the same, Jeremiah?
They don't look the same, but they do got the same cool stuff.
Okay, so they don't look the same, but they both have the point stuff, you said. They both have the points. Is there anything else you can tell me? What's different about these shapes? Different.
Can we do a circle? I got nothing.
This part is more longer.
Okay, so this part is more longer, you said?
This part is more.
It's important to start now when the children are young, looking at those different types of triangles, rather than waiting till they're older and they already have a more set notion of what they think a triangle is. How many points do they have?
3.
3. And does this triangle have 3 points also?
Yes.
Okay. And how many sides does this triangle have?
3.
3. And what about this triangle?
3.
3. I'm going to tell you to find one shape in my mystery shape bag, and you're going to use your hands to feel inside.
I pee.
No, you cannot look. And you're going to find the shape, but just by using your hands to feel, okay?
Let's feel the size.
Okay, you have to feel the size. Now, when you pull out your shape, you're going to tell us how you knew that you had that shape, okay? Feel around. Find the circle. When you find it, you can show us. All right, Marvell, you found
yellow.
the circle. Marvell, tell us how you knew that was a circle.
Feel these.
You felt those, and what is that? Tell me about that.
Circle was right here.
Okay, tell me about this side on the circle.
It was like this. I feel it.
So did it go around? So you felt the round side. Okay, put it back. Jeremiah's gonna find the hexagon.
Remember 1, 2, 3, 4, 5. You got 5 sides?
6.
6.
Oh,
Stop.
all right, Jeremiah. Okay, how did you know it was a hexagon, Jeremiah?
I feel the point stuff.
You felt the points? The point stuff? Okay, put your hexagon away. Oh, all right. How did you know that was the rectangle?
Because I felt the full side.
You felt but the square has 4 sides too.
I know, but I felt the long side.
You felt the long sides? Okay, and did you feel the short sides too?
Yes.
Okay, all right, let's put the rectangle away. Now, Lamaria, tell us how you knew that was a circle.
I knew it was a circle because I thought where it was.
You felt where it was?
Yes.
What did you feel? How did this feel to you?
It was a circle, but I touched it.
And what makes this a circle?
It's a circle because people make it of New Jersey or something.
Can you all help too? What makes it a circle?
Because it's round.
Because it's
yellow.
not. A circle doesn't have to be yellow. A circle has to be round, right? Does a circle have any points on it? Nope, no points. I'm pleased with the start that we have in talking about shape attributes and using shape language, and I'm looking forward to continuing this exploration with the kids in the classroom.
So I hoped you enjoyed that visit to a preschool classroom and listening and watching some children doing some really careful thinking. I'm wondering what thinking you might have noticed. Those children were really trying hard to describe the shapes using attributes. The teacher kept asking, what makes it a triangle? What makes it a circle? What makes it a hexagon? How do you know? Every time she asked them, how do you know? One child said that at the beginning that the circle was round and it had no pointy sides. And then there was that interesting point before they even got to the grabbing the shape part of the activity when they were just looking at the book where the one child says, it's upside down. And the other child says, no, it doesn't matter which way it's pointing. It's a triangle is a triangle. I probably have the words wrong, but the child says something like that. And the other child turns their head, to show that it really is the same, even though it's upside down. So this teacher is taking quite a long time with each group of kids to help them think carefully about what it is that makes a triangle a triangle. Mm-hmm. And she particularly spent a long time on triangle, as she said in her comments, because kids, it's one of those shapes that kids often have this idea. Triangle only is an equilateral triangle sitting flat on a base. And that's what they think triangle is when they're 3 and 4 and 5 years old. But if you keep asking questions and having them look at different kinds of triangles and notice that every triangle has 3 straight sides and it's got 3 points or 3 angles or 3 vertices, it doesn't really matter when they're in preschool exactly what word you use as long as they know what you're talking about. So the teacher also often reflected back the language it was that they were using. And these kids really engaged in thinking about it. They weren't always, right on top of what attribute was what, but they're only 3 and 4 years old. So that's what we would expect. And, at the end there, one child said it was a circle because it was yellow. And of course, circles can be any color. And the other child was trying to find the one that had been labeled a hexagon and was trying to count the sides while not looking at it, and counts either 5 corners or 5 sides and said, "How many does it have?" And she says 6. And then child says 6 and pulls it out. So they are really trying to think about the attributes in a variety of ways by looking at the pictures and by feeling for the shapes.
And I think, Lisa, what you point out too is the power of the learning community, so that some children might have a different understanding and a different way to think about these attributes, but they're also honing in on the power of their peers to be able to make comments about what they might be saying and build that understanding together, which is really nice to see in this video.
Right. And that brings us to some of the things that the teacher was doing, that we have evidence the teacher had thought very carefully about this. And we have some evidence because we got to see her be interviewed, but also just in the video with the kids, this teacher starts with a familiar book, does not read the book and try to talk about shape attributes, but says, remember this book we've read, and then get them to focus on a few of the shapes in there and talk about the attributes. Books are great jumping off points for math, but they have to be a book that kids know. It's not so good to spend a long time reading a book that they've never seen and then trying to talk about the math. They already had seen and enjoyed the book, the fun of it, and now she was helping them think about the shape attributes. And another thing that this teacher did was she didn't just have them grab into the bag and pull out a shape and tell what they had, or she didn't say to them, put your hand in here and find a triangle. She had these sample shapes on the table so the children have a reference point. So she could say, find a triangle and point to it, or find a hexagon and point to it. So they had something to see as a reference to help them think about what those attributes were when they were then feeling for the shape inside the bag.
And it's interesting because some of those reference shapes, like you mentioned before, didn't share the same color as the shapes that they were pulling out of the bag, which is a great provocation to be able to talk through that both of them could be circles, even if they're different colors.
And they also weren't even, I think, all the same size. Sometimes the reference shape on the table was a different size than the one that they were pulling out of the bag. Because again, a triangle is a triangle because it has 3 sides and 3 points. It doesn't matter which kind of triangle or how big or how small.
So it's a great way that the teacher can provoke those kinds of conversations and to be able to focus on those different attributes.
Right, on the thinking about the shapes, not just naming them. And she particularly, as I said earlier, she took a lot of time to focus on triangles because she knew from prior experience as a preschool teacher and in thinking about math that triangles are one place where children often have misunderstanding of what it means for a triangle to be a triangle.
And Lisa, one big takeaway that as I'm hearing you talk through this, I'm understanding a little differently is how the language that the teacher was using, that really descriptive language, helped students to make sense of these different attributes. Specifically, she was using a lot of gestures as she was talking about the round sides of the triangle and pointing to the pointy sides of, the round sides of the circle and pointing to the points or the corners on a triangle. A lot of gestures, which really is part of descriptive language to help the students understand this better.
Right. Our gestures very much amplify our words. And there is a lot of research showing that we can sometimes gesture about something before we can explain it. And that child at the very end talking about the circle, clearly, well, I don't know. I would think the child knew that the circle was round, but was one of the youngest kids in that group and didn't know how to explain it, but had some gestures with her hands and then was trying to say words. Well, it's just a circle because it's made of this. Just trying. She couldn't get her words around what it was that she knew from feeling it. And that happens a lot with kids, and gestures are very much part of how they develop the idea.
Absolutely.
So we earlier introduced 2 big ideas, one about sets and sorting and one about number sense. And both of them had to do with attribute. And we have a third big idea that also has to do with attribute. This is one of our big ideas of shape, that shapes can be defined and classified by their attributes. The teacher was clearly trying to get these children to explore that idea, that shapes can be defined and classified by their attributes. Just like I was trying to get the child with the rocks to classify or sort with attribute. We weren't defining the rocks by the attributes like a geologist would. We were just doing the classifying and sorting and describing. But here she's really pushing these kids to think about how it is that you define a shape. And we're spending a lot of time talking about this because so often in preschool, teachers approach shapes as vocabulary words for children to learn. That there's a lot of shape words and children need to learn the shape words, and children need to be able to look at a picture of a shape and say the right shape word. And that doesn't get you very far in really thinking about shapes. In fact, it often leads to the confusion that children have when they get a little bit older, when they don't realize that a square is a special kind of rectangle. Or they think that triangles have to have a pointy stuff going up. This teacher clearly understands that children really need to be engaging in mathematical and logical thinking about the attributes of the shapes. That's why shapes are mathematical. Shapes aren't just a vocabulary game, they're mathematical. And she made a lot of choices to help them think about the attributes of the shapes. Just like I was encouraging the child with the rocks to think about the attributes of the rocks, but that was a more open-ended thinking. And then here with the shapes, it's a much more guided thinking because there are specific geometric and mathematical attributes of shapes that are important to learn so that children can build their mathematical understanding and later on in life be able to do some more formal geometry.
Thanks, Lisa, for sharing that third big idea. So thinking about all three of those big ideas that we've talked about so far today, we see that the concept of attributes is present in all of those big ideas that we've already discussed. So we started our session today with talking about that balloon photo activity around attributes as part of sets and sorting. So we had talked about how attribute is really important when we were trying to decide what kind of things that we were counting. Were we counting the balloons or the balloon strings? Or were we counting the balloons in the front or the balloons in the back? We needed to focus on the attribute so that we could understand what we were actually counting. We also talked about how attribute is present in geometry, as we use attributes to help us, like Lisa mentioned, figure out what kind of shape is it. So we saw in the video the two triangles that the teacher showed the students. They look different, but we know that those are both triangles because they both had three sides, which is a defining attribute of shape. Also, we see that attribute is present in measurement as we try to determine what kind of big something is. So in the first video with the rocks, the little girl was sorting the rocks, and at first she was thinking about big rocks versus little rocks. And then her language became more precise as she talked about heavy and not heavy.
So you know what? You know what, Joanna?
Yes.
She does talk, the child did talk about heavy and not heavy, but she ended up making her groups, the big ones and the little ones. And I'm wondering if that attribute of weight, that kind of big, was something she was really interested in, but it's really hard to decide just holding rocks in your hands exactly which ones are heavy and not heavy. So she spends a little time talking about that, but then she can't really figure it out or be precise enough about it. So then she ends up making her groups of the big ones and the little ones. But this idea in measurement that there's a lot of kinds of big, she just talks about big and little. For a little while, she thinks about heavy and not heavy. But there are other kinds of big and little too, like tall and short, or wide and narrow. You know, and you have to be focusing on an attribute to think about which one is bigger and which one is smaller. How are we looking at it?
Because long and short is very different from heavy and not heavy. But heavy and not heavy are much more precise or long and short than if we're just saying big and little, as we try to determine what kind of big or what kind of little it is. And we also know that attribute is present in data analysis. So as people collect and analyze data, we know that we're sorting through that data and making sets of it. And we see this in children, but even as adults, this is the way that we're being able to sort through data and make sense and understand it. So really, I think the big key takeaway here that Lisa and I want people to be sure that you understand as you're after this session is that attribute is a key concept in all areas of math. It's not just part of one big idea, like we can see on the slide here. It hits across many of our key concepts in math. So this is really something that we want to make sure people take time to understand and how we can support that with young children.
So we've had the chance in this session to really dig into three of our big ideas. The big idea that we use attributes to sort, and the big idea that we quantity is an attribute, and the big idea that we define shapes by their attributes. So those are three big ideas that we've really had the chance to talk about with you now. And you can see right now there's a picture of the cover of a book called The Big Ideas of Early Mathematics, What Teachers of Young Children Need to Know. And the members of the Erikson Early Math Collaborative wrote this book together several years ago. And in the book, we have 26 of these big ideas. They're organized by general math areas. We have a chapter on sets, a chapter on number sense, a chapter on number counting, a chapter on number operations, a chapter on pattern, a chapter on measurement and data analysis, and another one on spatial thinking, and another one on shapes. We have 9 different chapters and 26 big ideas. Those of you quick math thinkers might think if there's 9 chapters, maybe there should be 27 big ideas because there'd be 3 for each chapter. It's kind of funny. For some reason, we have 3 for most of the chapters, but one chapter only has 2. So we have 26 of these big ideas. And in your handout packet, you actually have the 9 charts that have those 26 ideas. I wanted to talk with you a little about, what is a big idea? They're these key mathematical concepts, and they really do. They lay the foundation for learning. They're the things that are being explored by preschoolers, as we saw in the 2 videos, but they're very powerful, and we'll continue to engage with them for years to come. We're still thinking about attributes as adults in math and in other areas. And we're still thinking about definitions of shape. Like I said, when you do formal geometry, that's still an underlying key idea. But if it's a big idea of early math, it's something that 3, 4, and 5-year-olds can really think about. But we didn't want to include something as a big idea if it wasn't something that was also going to last and engage for years to come. And another important thing about big ideas is that they're to help the teachers or other grown-ups focus and clarify their goals for children's learning. That's why we have the big ideas. We do not want anyone who works with preschoolers to take the charts we gave you and go away and try to get all your children to be able to recite the big ideas back to you. That's not the point of the big ideas. They're exploring what they mean in activities like sorting rocks or describing shapes. But the big ideas are definitely not for those kids to spout back to you. They're to help you as an adult understand what children are exploring and thinking about. So, I sort of said this with the last slide, but I just want to take my time on it because I think it's really important. A big idea is big because it's mathematically central and coherent. If you look at that big idea, you can see how it connects to mathematical thinking that happens in elementary school and middle school, that happens with adult professional mathematicians and engineers. We can see that it's an important idea and makes sense. But it's also consistent with children's thinking. It's where they are, and it will generate future learning. So that's what makes an idea big. That's what we had to think about when we were choosing what were we going to put in the big ideas and how were we going to state them. And as I said again, big ideas are these tools for adults to help we adults understand foundational math and notice and plan for children's learning, because we might think we know math for preschool. We can count, we can do simple arithmetic, we can sort, we know shapes, we know all the math there is to know. But if we don't think that children have to think about what is an attribute and what am I going to call that set? You know, when I kept pushing the child to say, what are you going to call these ones? Until she finally says the little ones. It's because I really wanted her to think of the logic. You took this attribute little and you're defining this set. And if I hadn't dug into what is the underlying idea of sets and sorting, I might have just been happy that she made the two groups, and I wouldn't have realized why it was important to get her to say, these are the big ones and these are the little ones. So my understanding of the foundational math helps me help the child learn. Or the teacher doing the shape activity with the children, her understanding that the logical thinking about shapes is in defining them with their attributes, helps her plan how to do that with children and not just have it be like flashcards. I'm going to hold this up and you say triangle. Great. I'll hold up this other one and you say circle. Great. You know your shapes. Understanding this foundational math allows her to plan for children's learning and notice the math that's happening all around us. Because, you know, attributes are great for sorting activities in the classroom or defining shapes, but attributes are also terrific if you're trying to figure out what's in the lost and found and what to do with it. Or attributes are important when you're trying to put away a big mess of toys. Or if children are at home, attributes are very useful in trying to do the laundry and get things in the right places when the laundry is done, or empty the dishwasher and put things away. Those are all places in which children can be thinking about attributes, and we know that they're building their mathematical understanding.
I think that's such a key point that you bring up, Lisa. I think a lot of times with teachers that I've worked with around the big ideas, it's an aha moment sometimes when they realize, like you mentioned, that math for young children is not that rote memorization, flashcards and labeling and being able to just name shapes or identify numerals. That math is really a foundational in how children are constructing this understanding through so many different content areas and concepts throughout math. The big ideas really help to bring that to life for the teacher so that that teacher can be able to provide those experiences, those rich experiences around these big ideas of early math in the classroom.
Yeah, we have, I've met someone at a conference a couple of times who likes to say that people understand the message about learning to read, that they may not know everything there is to know about how the brain learns to read or the absolute, most useful techniques, but they have this message that we should read books with children every day, right? We've got that message, and we're hoping that the big ideas will help us understand some messages like that about math, that we should ask questions with children and we should try to solve problems with children. And that's something that we can do in that same way that we know to pick up a book. We know to ask questions and try to solve problems and respect children as thinkers using these ideas about what it is they might be thinking about.
Absolutely, absolutely. That's a great reference point. So if Lisa and I haven't already convinced you on how important the big ideas are, a few more things that I wanted to note about why big ideas. So building on what we've already talked about the big ideas, We know that precursor math concepts and big ideas deepen a teacher's knowledge of foundational mathematics. So just like we were talking about, it's, again, different from those basic math facts. Foundational mathematics really focuses on students constructing their own understanding. That means that they have to have many, many hands-on experiences to be able to construct this understanding of the big ideas, of the concepts around the big ideas. And we know that the role of the teacher is to support the children in building those ideas. So teachers need to have thought carefully about these big ideas. This is particularly important because that we know that as teachers expand their knowledge, it helps teachers to feel better and better prepared, more confident as they're carrying out these activities, these experiences in their classroom. So we need to be able to help the teachers to understand this so that they can, like we mentioned, bring these experiences into the classroom. And we also know that knowledge impacts practice. So as you can see in the bottom corner here, a lot goes into the development and of a teacher. So we know that attitudes and beliefs, classroom practices, and knowledge and skills all come together and overlap to lead to the development of that whole teacher.
Right. I'd love to jump in a second, Joanna, and say that, as I don't know how many of you listening to us are yourselves preschool teachers, but I expect some of you are. And probably the rest of you work with preschool and kindergarten teachers. And we have this idea in early childhood that it's really important to think about the whole child. Think about how the child isn't just a skill learner or a thinker, but the child is also somebody who's feeling and someone who has physical needs. And we need to think about all of that and put it together. But so often when we think about teachers, we tend to forget that teachers are also whole people with different parts and different aspects of who they are and what they bring to the teaching task. And so often, particularly around math, teachers are just given, here's a curriculum and do it. Or here's, a math activity, come and learn this new math activity, which can be really fun, and take it back to your classroom and do it. And that can be terrific. But if you haven't thought through more about it, thought about what is the math in there and what are kids thinking about and how does this fit with my understanding of math, it's not really going to have the same kind of effect we might hope it would have. We know that many people who work with young children did not love math when they were in school. Some of them did, but many of them didn't. And so part of our coming to the big ideas and writing the book about the big ideas was to give teachers something that helped them feel more comfortable and happy about math, because so many of them thought, math, I can try to do as little of that as possible. I'll find, a good workshop, I'll find a good curriculum and I'll do what they say and then math will be over with. And we want the whole teacher to be involved in math to maybe change their attitude and think math is more fun and dig into what math is and then really engage with the children around them. So that's why we think it's important to treat the teacher as a whole person. And if you're a teacher, to treat yourself as a whole person. You aren't just a robotic person who does exactly what the curriculum says. You are yourself a math doer and math thinker engaging with children.
Absolutely. Great points, Lisa. And then finally, a few points to summarize. We know that big ideas are useful regardless of the activity. So big ideas, again, exist outside of specific activities, curricula, standards. We know that big ideas are easy to remember. So like Lisa mentioned before, they're not a laundry list of skills. These are big concepts that are helpful and easy to remember, and they help teachers to mathematize play. So just like we were talking about, as teachers know and understand the big ideas, they're able to infuse those concepts into the play and help really mathematize it. And finally, big ideas help to put the focus where it belongs. We've talked about this. We thought about it as we were watching those videos. It really helps to put the focus on thinking and understanding. So again, it's not about those rote memorization skills. It's about the understanding and the thinking that the children are engaging in as they're engaging with these big ideas. So as Lisa mentioned today, as a reminder in your handouts, we talked about 3 big ideas throughout the session today, but in your handouts, you do have all of the big ideas that are also printed in our book as well. And you also have the slides in your handouts so that you can go back and you can always reference those to help your own teacher development, or like Lisa said, if you're working with preschool teachers, to help their development by expanding their knowledge and helping them to understand these concepts more deeply.
Yes. We don't have this actually, I think, on any of the slides today, but we're talking about these as being the big ideas of early math. And sometimes that might beg the question, so what's math? And we like to say that math is a logical way of thinking that allows for increasing precision. And I think Joanna did say those words before, but I'm not sure they're printed anywhere. Math is a logical way of thinking that allows for increasing precision. And we also like to say that we use math to make sense of the world, and we use math to solve problems. And the big ideas are an important aspect of understanding this logical way of thinking and helping children to make sense and helping children to solve problems. Because we don't want people to think that math is just what they might remember from school math, flashcards, algebra classes, geometry proofs, all those things. Those are part of mathematics, but mathematics is also an amazing human endeavor. Every human being does some sort of math every day. And we want people who work with young children to enjoy that. And we hope that the big ideas, through their simplicity and their logic, move you towards loving math as much as we do and having fun doing math with children, not dreading it at all.
Great point, Lisa. Now we'd like to shift to be able to have some time to answer some of the questions that you all have written throughout the presentation. So if you haven't written your questions yet, feel free to take a moment now to add those questions.
And we know there are very many of you listening to and watching this presentation, and we'll get to as many of the questions as we can, but it's certainly possible we will not answer your particular question. And we do enjoy hearing from people, so do feel free to contact us directly if you want to follow up with us about something. And also, please check out our website, earlymath.erikson.edu, because you can get a lot of answers and ideas there as well.
And the videos that we showed today are also available on our website, as well as a ton more videos, resources, and like Lisa said, great ideas as well.
Yeah, and there was a question somewhere in the list of questions about adapting things for toddlers. I don't like to think about adapting great preschool activities for toddlers. I like to think about, what are toddlers like and how can we do math with them? And some colleagues of ours from the Erikson Institute in Chicago had a session, the breakout session before this, called More, Said the Baby. That was really a lot about having attribute conversations with infants, toddlers, and twos. And all of these sessions have been recorded. And if you registered for the symposium, which you clearly did because you're here, you will get at some point, I don't know when, tomorrow, next week, I don't know, sometime soon, you will get information about how to get to the recordings. So if you didn't go to the More, Said the Baby, and you really want to think about infants and toddlers, then, and they're thinking and they're beginning to think about attribute and what does it look like for them, please go and watch that. And we don't, someone's asking about handouts for parents. I don't know that we have, I'm not sure what you mean by that, but if you go to the earlymath.erikson.edu, which I put in the chat box, it's also on our handouts in the session materials. If you go there, there are certainly posts that really are aiming at parents. We particularly in these last few months, when we knew that many parents were spending more time with their little children and trying to think about how to do it, we've been trying to post more. We've been trying to post some more things that would be appropriate for families, and we're ideas about like how math is there when you're doing the laundry or doing the dishes or taking a walk. And we are very, very close to the end of our time.
Let's also note, I know a few people have asked about the book. The book is available on the NACCE website for purchase. That's the cheapest place I think you can find it, the best price for it, especially if you're a NACCE member. Or you can also find it on Amazon as well if you're interested in the early math in the book that we had talked about.
And someone asked about Spanish. We do not have the book translated into Spanish yet, though it is available in Mandarin. But there are not all of the posts on our website, but several of them are available in Spanish. You can click on a thing in it and you get it in Spanish instead of English. And we've been particularly trying to do that for ones that we think are relevant to share with families. And I think that might be our time. Thank you very much
again, everyone.
for being so engaged. I hope you had a great day.
Thanks, everyone.
Bye.